Welcome to General Structures 2 and Lateral Forces, lesson number 2, example number 3. And it asks us, actually it says, a three-hinged arch with a rise of 20 feet spans 100 feet and supports a uniformly distributed load of 1,500 pounds per foot. What is the horizontal thrust at each end of the arch? And first of all, let me go into a bit of some explaining. And you'll have this reaction, vertical, and then you'll also have this horizontal reaction coming in like so to resist, because this will want to push out, kick out a little bit. So they actually have an equation for this, which if you look on the previous page of 42, you can see that the equation, and you'll see it over there, it says H, which this is H. They call this H and they call this V. And it's similar for both sides when you have this is WL squared over 2, with L being L. And then this is 20 foot equals H. We'll call it little h. And let's see what they do. They actually call it little h over there as well. And they call this big L. But anyways, same thing. Alright, and then we also know that H, as I say, equals WL squared divided by 8H. So we don't need to write it down here again, but we will. Over 8H. And let's just go ahead and fill in your answers. For W, we have 1,500 pounds per linear foot. And if it's easier for you, you could just put pounds per foot, because some people like to cross out their, when you're doing the equations, to cross out their units, and it makes it a lot simpler, but I can see how you could do it either way. Just whatever you get into a habit of doing, and whatever way works for you, please do it that way. Alright, L, which we want to use it in foot because we have foot right here. For some reason, if you're doing it in inches, I typically work in foot when it comes to this, and then once you go to deflection, I'll turn it into inches. But for now, we are in foot, and I'll use foot. I'll square it. I take all of that over 8H, and as we said, H is 20 foot. Then all you have to do is get out your calculator and do 1,500 times 100 squared divided by 8 divided by 20. Or you could do that in your head. And I get 93,750. And I'm guessing that's going to be in what? Pounds. So that equals 93.75 kips. Let's check that with the answer they got. 93,750. So they got the exact same number. 93,750, and that's what you need to resist. So when you set up the realism of this is you're going to have to set up a support here that will resist that type of horizontal load. And let's go ahead and take a quick look at the vertical load as well. And this is going to be the exact same as if it were a beam, the horizontal projection of it. So let's just do that real quick. 1,500 PLF. I could probably do this in my head, but I won't. 100, so I put 2 zeros to it. Oh well, I won't do it in my head. And that equals, so I guess head math, what is it? Add 2 zeros, it's 150 divided by 2, 75,000. Let's put in the calculator. 1,500 times 100 divided by 2, 75,000. I think that's what I said. I might have said 7,500, but I meant 75,000 in my head. Alright, anyways. And that is pounds. Alright, so as you can see, 75,000 pounds versus 93,750 pounds. So it's actually a higher horizontal load on each side than it is a vertical load, which is just something to take note of. And like they do in the solution, they're saying what would thrust be if the rise were 30 feet. Let's do 40 feet instead, just to see what's the difference, and hopefully you can see that the higher the arch, the less kick out there will be. I hope that makes sense. The higher it is, the less kick out. The higher it is, the less kick out, because essentially you're coming in at an angle here. Whatever this angle is, the higher the angle, the more you're going to have to. If you're coming in like this, you're going to have, for instance, let's say this is coming in like this, and this is going to be compression, and that component will be right here and right here. So if you have something like this, that horizontal component of that is going to be a lot less. So let's just make sure that that assumption is correct. Let's go ahead and take a look. And let's say, it looks like in the example they said 30 feet. Let's go, oh heck, let's make it 50 feet. Let's say this new one is 50 foot. And let's see what that difference is. You see what the H of 30 is. Now let's do H of 50, which is, it's not very much difference at all. H, which is horizontal load, which I don't like using that big H. I like that using that big H for height. But let's move on from that. That's going to be confusing. We still have the same equation, WL squared over 8H, and that equals 1500 PLF times, right, remember we have the same L, over 8 times 50 foot. And it should be, what, 93,750 divided by, or times 20 divided by 50. Or just do the math from the beginning, and you get, that can't be right. I forgot to square it. There's a dummy check for you. 1500 times 100 squared divided by 8 divided by 50 is 37,500 pounds. So as you can see, the only thing that really changed was this right here, and from this right here. And as you can see, we got it quite a bit less. So it's going to be a linear change from the amount you do to the less. And in other words, I could have multiplied this 20 foot divided by 50 foot, and I would have got this answer right here. So 93,750 divided by 50 times 20 equals 37.5, and that's what we got again. All right, so the higher that arch is, the higher the arch is, the less angle you're coming in at, the less vertical reaction you're going to have, or sorry, horizontal reaction you're going to have. All right, I hope that makes sense, and this should be how you can justify it to yourself, is if you're coming in, that reaction's compression only, it comes in at a low angle, you're going to have a minimal vertical reaction. Most of that's going to be transferred to horizontal, but if you have a steep pitch coming in, or slope, whatever you want to call it, most of it will be vertical and less horizontal. All right, that seems to be enough right now. If you have any questions, please post them, and I hope this helps, and I will see you on the next example, or I guess it might be the quiz.